Ever stop to think about that invisible shield all around us? I mean, this huge bubble of gas that literally makes everything on Earth possible. Well, that's what we're diving into today, our planet's atmosphere. So, what is it that keeps us safe from the total vacuum of space? It's a pretty big question, right? And the answer is, well, it's everything. It's the air we're breathing right now, it's our shield from crazy radiation, it's our planet's thermostat, it's the atmosphere. And yeah, without it, we just wouldn't exist. Okay, so here's the game plan. We're going to look at what this protective bubble is all about, then check out the main ingredients in the air. After that, we'll take a trip all the way up to space, see how we've had an impact on it, and finally, look at the whole thing as a system in motion. Let's get to it. You know, when you really think about it, the atmosphere is like the planet's ultimate multitasker. Seriously, it gives us the air we breathe, obviously, but it's also got this built-in sunscreen that zaps harmful UV rays. And on top of that, it's like a giant global thermostat, holding in just enough heat to keep Earth from being a frozen rock. Pretty amazing. But get this, it wasn't always this nice, breathable air. Nope. Go back about 4.6 billion years, and Earth's atmosphere was basically all carbon dioxide, super toxic to us. Then, over billions of years, something revolutionary happened. Photosynthesis. Little plants started sucking up all that CO2 and breathing out oxygen. And that right there completely changed the game. It gave us the nitrogen-rich atmosphere we have today, which is what allowed complex life, like us, to even show up. All right, quick pop quiz. If I asked you what gas makes up most of the air we breathe, what would you say? Most people jump straight to oxygen, right? I mean, we need it to live. But that's not actually the right answer. The real heavyweight champion of our sky is something totally different. Okay, take a look at this. The breakdown is kind of shocking. A massive 78.1% of the air is nitrogen. 78%. Oxygen, the stuff we can't live without, is a distant second at just under 21%. Then you've got a little bit of argon. And all the other gases we hear about, like carbon dioxide, they're all crammed into that teeny tiny little sliver that's left over. So, why so much nitrogen? What's it even doing? Well, for one, it's super stable, so it doesn't just react with everything, but it's not just taking up space. It's a key player in what's called the nitrogen cycle. It's constantly moving between the air and living organisms, providing nutrients that are absolutely essential for life. Okay, time for a field trip. Let's imagine we're hopping into a super fast elevator. We're gonna press the up button and not stop till we hit the edge of space. Along the way, we'll make a few stops to check out each of the 5 main layers of the atmosphere. Ready? Let's go! Ding! First floor, the troposphere. This is our stop. This is where we live. It goes up about 10 kilometers, and it's where all the action happens. All the clouds, all the rain, snow, wind, basically all weather. It's also super dense, packing in about 75 to 80% of the entire atmosphere's weight. And just like climbing a mountain, the higher you go here, the colder it gets. All right, elevator's going up. Next stop, the stratosphere. It's way, way calmer up here. This is why airplanes love it. They can cruise above all that bumpy weather. But here's the weird part. The temperature flips. Instead of getting colder, it actually gets warmer the higher you go. Why? Well, this is where the famous ozone layer lives, and it's busy absorbing a ton of UV radiation from the sun, which heats the whole place up. Okay, on we go, climbing higher into the mesosphere. Now, you might want to grab a jacket because this is the coldest place in the entire atmosphere. It's absolutely frigid. And if you've ever made a wish on a shooting star, you've seen the mesosphere do its thing. It's our cosmic shield. This is where most meteors slam into enough air to burn up, creating those awesome light shows in the night sky. We are getting way, way up there now. Welcome to the thermosphere. And the temperatures here are just wild. They can soar up to 2,000 degrees Celsius. But here's a mind bender. Even though it's technically super hot, you'd freeze instantly. The air is so thin, there's basically nothing there to actually transfer that heat to you. This is also the home of the International Space Station and those incredible dancing light shows, the auroras. Ding! Top floor, the exosphere. This is it, the final frontier. It's not really a hard line, it just fades away. Our atmosphere just gets thinner and thinner until it blends into the blackness of space. The air particles are so far apart here that some just float off and escape into the cosmos. It's also where you'll find most of our satellites, silently orbiting the Earth.
So as you can see, this whole layered system is an incredibly complex and delicate shield. And for a while there, our own actions were actually punching a hole in it. Let's zoom back in on that ozone layer we mentioned, because it's a really powerful story about our impact and what we can do about it.
The story really kicks off with these chemicals called chlorofluorocarbons, or CFCs. Back in the day, people thought these things were miraculous. They were totally safe, super stable, and perfect for stuff like spray cans and refrigerators, a real wonder chemical. But that exact quality, their incredible stability, was also their hidden danger. It was a ticking time bomb for our atmosphere. So here's the chain of events. A CFC gets released from, say, a can of hairspray. Because it's so stable, nothing on the ground can break it down, so it just floats. For years. It slowly drifts all the way up to the stratosphere. Once it's up there, the sun's intense UV radiation is finally strong enough to blast it apart. That releases a chlorine atom. And here's the scary part. Just one of those chlorine atoms can go on a rampage, destroying thousands and thousands of ozone molecules. And this is what that destructive cycle looks like. You can see the single chlorine atom acting like a little wrecking ball. It smashes into an ozone molecule, steals an oxygen atom, and then it's ready to do it all over again, and again, and again. It's a terrifyingly efficient process, and it's what started thinning out our planet's vital sunscreen. You know, the ozone story is a really powerful lesson in how human actions can have these huge unforeseen consequences on our atmosphere. And that brings us to another major conversation happening right now, one that involves a different aspect of our atmosphere, the greenhouse effect. Okay, first things first, let's get one thing straight. The greenhouse effect itself is totally natural, and it's a good thing. We need it. Think of it like a blanket. Certain gases in the atmosphere trap some of the sun's heat and keep our planet cozy and habitable. Without it, Earth would be a frozen wasteland. So the debate today isn't about the effect itself. It's about the enhancement of that effect. The idea that human activities are adding more of these gases, making the blanket thicker. Now, this is where things get into a really passionate public debate. There are different viewpoints out there. One perspective that you'll find, which is reflected in our source material, argues that the rise in CO2 isn't really because of humans. Instead, it's seen as just another part of a natural cycle, something the Earth has gone through many times before. On the other hand, the source material also presents a different take. This view states pretty clearly that the increase in carbon dioxide we've seen since about 1900 is mostly a result of human activity, specifically from burning fossil fuels that we've pulled out of the ground. So you can see, these two ideas really get to the heart of the whole discussion. And that really leaves us with a huge question to think about. This atmosphere, this incredible complex shield, took billions of years to become what it is today, a system that allows life to thrive. So the big question for all of us is, what will our choices make possible for its future?